just write it like this first. So this is the principal value of the YOC for the last 3 years, right? But that principal value is at the beginning of those 3 years. But now you want to bring it back to time 0. So that means you further divide by 1 plus I to the power 7, right? So the net becomes to the power 10. I want to really make sure you guys understand this. Because if you understand this completely, that means now you really understand how to move money. Okay? So I'm going to let you have a couple of minutes to think about this, digest this. And you can see, so yeah, we have our best option. Now the interesting thing is that which one is better? Buying more expensive equipment early or later? That's the interesting thing, right? You see, earlier is better.
Should be 2 instead of 20.
Sorry?
For the yearly operating cost for the last term of the one that's cheaper.
Yeah, it is 2. I have 2.0. You guys are sure about the calculations, right?
Label we got.
Sorry?
Label we got when you're doing so the first one we're buying.
So the first one is
Option 3 plus.
option 3.
No,
option 1.
Option 1 plus 3.
Yeah, 1
So
then
1 plus 3. And this is 3 plus 1. This result surprises me. That's why. Are you guys sure your calculations are right? We are paying for pump 3. We are paying for this in the beginning. Here we are paying for this after 3 years. Right? And this takes care of YOC for pump 1 for the first 3 years. This takes care of YOC for the pump 3 for the next 7 years. And similarly here for the first 7 years and next 3 years. Okay, it's okay, yeah?
Why does it surprise you? Wouldn't it make sense? Because you have to spend more money in the future. It's something.
But usually it's better to spend money as late as possible, right?
Yeah, we got the.
Huh?
But 7 years versus
Okay.
2.
Shh, no, okay, what are your numbers?
Yeah, the first one's 39, and the second one's 39.
39.8. I believe those numbers more. I want somebody else to check because otherwise the number
I got
doesn't make sense to me.
39.8 on the bottom one.
Sorry?
I got 39.8 on the bottom one.
Okay, and this is 39? The top is 39, this is 39.8, right?
Yeah.
Yeah, that makes sense to me. I think somebody made a mistake in the first calculations. Because this makes sense because, yeah, you want to postpone. Also, if you think about it, if you keep buying equipment to perpetuity, option 1 is the best one. So you have to go with that. Yeah, with that in the beginning. And of course, towards the end, the life starts playing a role and therefore you buy the more expensive one. Okay? So this makes sense. Yeah. To the 10 because see again I'm trying to do this of course a little bit fast because I've done a lot of problems like this. You should always, anytime you have problems like this, what should you start with? Cash flow diagram, right? You should draw a cash flow diagram. So let me just draw it and then you will see. So let's look at this option. So this is your time axis. You have to buy an equipment here. So we are doing, which one are you doing? We're doing, let's say 3 years for, right, and then 7. So you have to spend for 3 years 10,000, right? So you spend 10,000 and then you keep spending YOC, which is 222. Now this point in time, you have to buy another equipment because this equipment is not going to work anymore, right? So now you add 20,000 to it, right? And then of course for the next 7 years, you're going to put the YOC. 1, 2, 3, 4, 5, 6, 7. So you can see this will be so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it, you're done, right? Okay, all right. I mean, you can also have point here because that's the end of year 10, but you don't have to spend any money, so it doesn't really matter. So, all right. So now these numbers are what? These numbers are 2.5. No, yeah, 2.5. Right? So now of course the question is, you want to bring all this money to time 0 so you can compare options. Right? So there are different ways of doing it. One is you can do term by term. But we have learned annuities. The reason we learned annuity formula so we can use them. So this 10K is easy. You just have 10, right? And then 20, you're paying 20 at year 3, so you have to bring it back here to divide by 1 plus IQ, right? Okay? Now you could have made 22 here, but if you do 22, it doesn't really help because the rest of it is kind of a change annuity. So you said it's 20, and then this is 2, 2, 2, 3 terms, so you just sum it up as an annuity. So that part is easy, right? Just calculate your principal value. Then you look at this 2.5. You convert this to an annuity, but when you convert and get the principal value, where is that? The principal value is the value where? Huh? At 3. Right? It's the value here. And so then you want to still bring it down 1, 2, 3 back to time 0. So that's why it would be 7. That would give you the principal value at time 3. Then you further divide by 1 plus I cube to bring it to time 0, right? Or another way of thinking of it is, don't think of principal value, think of future value. The future value would be without these terms, and the future value is at the end of the annuity, so the future value would be at this point, right? And then of course you move it back to time 0. So that straight away gives you a percent per 10, right? All right, does it make sense? How much time do we have left?
5 minutes.
So yeah, again, I'm gonna let you think about this. I did want to do one more concept today. Can I move on? At least explain that concept.
Yeah.
So this is great. This is one way to evaluate which equipment is most profitable, which is the best to buy. There's another way to think about it. Now, really, both of these methods are really the same. It's just like saying you add 3 plus 7. Everywhere is a different way of adding, right? Some people are going to do 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, and 10. Somebody will say, oh, 3 plus 7 is 10, right? The method I'll explain now is not different method. It's just another way of looking at it. So the alternate way of looking at it is, so in this case, what you have done is, you have brought all the money to time 0, right? An alternate way of looking at it is to say, I'm going to distribute my cost of buying the equipment into an annuity year by year. Does that make sense? So instead of bringing YOC to time 0, I'm going to take my principal and distribute it year by year, right? And that's called EAOC, Equivalent Annual Operating Cost. Okay, so let's calculate EAOC. Sorry? EAOC, Equivalent Annual Operating Cost. Equivalent Annual Operating Cost, okay? So what will it be? It will obviously have a term YOC, right? And that's the real operating cost. The second term has to distribute the actual cost into an annuity. So what do you think the second term will be? Huh? The principal value of the annuity? It's the reverse. Yeah. We know the principal value. What am I trying to calculate? Yeah? Sorry?
Maybe by the principal by the number.
Not maybe. If you think about it, you know the answer. Then You have the answer. What is it? Is it baby or the answer?
So I think you divide the principal by the number of years and then move it to the inside.
You can never do that. We discussed this. What's the major flaw with dividing it by the number of years? You can never put money at different points in time and give it equal weightage, right? Yes.
Instead of using P equation, use annuity and then solve the annuity value.
You calculate, yeah.
It's P 1 plus I times I over 1 plus I the I minus 1.
Excellent. Yeah, what were you going to say? Somebody had a hand raised?
Yeah.
So in this case, you know the principal value, you're trying to calculate the annuity, right? So, and you can use the same formula. P, remember, is annuity A, 1 plus I to the power n minus 1 divided by 1 plus I to the power n minus 1. Oh, sorry. Right? In this case, we know P. We're trying to distribute it into an annuity. Right? What does this remind you of? What kind of calculation? A calculation to do what? When I started this class, I talked about a dream of mine. Buying a car, buying a Lamborghini. Where you know the value you have to buy today. I actually saw one in Boston. When I was in Boston, I was at a restaurant and there was a Lamborghini parked outside. So I told my friend, if you're ever thinking of a birthday gift for me, that would be a good one. Okay, all right. So from this you can calculate plus P, which is the cosmetic P, 1 plus I, P times I times 1 plus I to power n divided by 1 plus I, right? And if you think about it, if you look at EAOC formula and if you look at CC, what do you notice? How are the two related? Okay, you multiply what by I? You multiply CC by I, right? So EAOC is simply I times CC. Why? So yeah, we calculate the two things and this is what we observed. This is actually obvious if you think about it.